Okay, so now what we're going to take a look at is a little bit of stuff about derivatives, some extra information that you're going to need to know. So first of all, just to make sure we're thinking about the right stuff here, let's take a look at the first part, which says find the equation of the tangent y equals root x that is parallel to this line. So there's some information in there that, again, you really can't lose sight of what the derivative is. The derivative is finding the tangent line's slope. It is also describing a rate of change. You really have to remember those because sometimes if you go on algebra alone, it's not going to help you. So what's the clue in here that we have to use? There's a clue that we have to use to help figure out this equation. That's right. So here's the clue. If it's parallel to this graph, there's the slope. So they have to have the same slopes. So we've already figured out from the previous one that the derivative is 1 over 2 root x. So we can use that information now to say, where does that equal to 1/4? Now, some of you could use some quick common sense. Some of you can go to the trouble of solving. What do you think? Common sense or solving?
Common sense.
Okay, so common sense answer would be? 4, yeah. So x equals 4. If you can't do it the quick and easy common sense way, then I would probably end up cross multiplying this to figure out the answer. And all blah, square both sides, all that kind of stuff. So if we've got x equal to 2, or sorry, x equals to 4, that's where it is going to have a slope of 1/4. So what will the value of the graph be there? Well, we have the point y equals square root 4, which is going to say y equals to 2. So now I have a point. Whoops. Now I have a point, which is 4, 2, and I have a slope. So I can use that to figure out what's the equation of the tangent line that's parallel. So it'll be y minus 2 equals 1/4 x minus 4. So y minus 2 is 1/4 x minus 1. So I believe we're going to have y equals 1/4 x plus 1. Okay, so I'll show you in the picture again what it is that we just did there. I'll move it over in case you're still writing. So we had y equals the square root. So that's the graph that we're taking a look at. And the line that we were asked about was originally 1/4 x minus 2. So let me change. Let's go to, say, -6. Okay, so there's the square root graph, and there's its the line. Maybe I can make a better picture here. Let's go -3. Okay, so I want one parallel, and the equation that we figured out just now was 1/4 x plus 1. So there's the two parallel lines, one of which is tangent to the square root graph. So the only real part of that was that you had to click in that the derivative is the slope. Use the slope to figure out where you are on the graph. In this case, it's the point 4, 2. Okay, so we're going to take a look at another definition of derivative. Okay, so there's the one we've just worked on where delta x goes to 0. Another one which can be convenient sometimes is the one I've listed here. And let's just go over how it comes about. So I'm going to show you on another slide rather than try to cram it in. But it comes back to using the slope formula again. So for the slope formula, this is the slope formula. And what we're going to do instead is, let's say this is the point x, and this is the point C. So from that, I get one of the non-calculus secant lines. Okay. Maybe I'll try and make it a bit straighter. See if I can do any better here. There we go. So I get one of the non-calculus lines that uses 2 points. Okay. And what I want to do is if I want to get the tangent line, I have to move this value c until it touches x. So what would happen is, as it's being moved over, right, it's approaching that tangent line until it's actually touching right on it. Okay. So if we were to write this with the limits, this would be the limit as x goes to c, which is what I'm trying to show in this picture here. X is moving to that, or sorry, I did it backwards there. Did I? Okay. We'll just pretend. We'll pretend that Mr. Joyce. We'll pretend that he said c and x. What's that? Nothing. Okay. As x goes to c, and it was f of x minus f at c over x minus c. Okay. So that's the alternate definition, is you move one point to the other point, not the change in x becomes 0. It's you move that one point until it's over top of the other one. And that's the alternate form here. There are some times when it's easier to use the alternate form than it is to use the one we've already talked about. And again, you're going to be expected to recognize this definition when you look at some of the questions in the Barron's book. So if we wanted to take a look and see, if this was better or not, let me show you for this one here. This would be 2 times x squared minus 3x plus 5, and subtract 2c squared minus 3c plus 5. And it would be over x minus c. So what's the problem here for this limit? What is the, what are we trying to remove? A little more than just the c. It's the x minus c that divides by 0. So this is what we're trying to remove if possible. So if we can, that's what we want to factor out. That's what our goal is going to be, is to try to remove an x minus c. So just so I don't cram it in, I'm going to go to a full-sized. Okay, so this is where we were. The limit as x goes to c of and let's see what we can do here. So one thing I could do with this is I could say the limit as x goes to c of 2x squared minus 2c squared. And you'll see why I do this in a minute. And
Is it minus 3x?
oh, is it minus 3x? My apologies. So this will be minus 3x plus 3c. And what else do we have here? Those 5s would disappear. So on the bottom I would have x minus c. So now I'm going to have to start factoring to see if I can take it out. So one thing I could do is I could factor this as 2 x squared minus c squared minus 3 x, let's just see here. Doesn't really look like a, there we go. Okay, x minus c. So I can see that one of these pieces has an x minus c, which is good news. I have to figure out how to get it out of this last one. Any ideas? Sure, Jenny? Yeah, it's the difference of squares pattern, right? So this one's going to become limit as x goes to c of 2 times x plus c, x minus c, and on the bottom. So that's good, because now that factor can be taken out of each piece. So I would say gone, gone, gone. And I would get the limit as x goes to c of 2x plus c minus 3. So as this becomes an x, it's going to be 2 times x plus x minus 3, which is 4 x minus 3. Okay. So that would be the derivative using the alternate form. That one I think is probably just as difficult either way. The square root, though, happens to be a good one. So to see that, I'd like you to try the alternate definition for the square root of x minus 2. Okay, so see if you can work it out and see if you like it better or not, but try the alternate definition for this example. Okay, so let's see if you're on the right track with this. If you've set up your limit properly, it's going to be the limit as x goes to c, and it's the function evaluated at x, take away the function evaluated at c. So this is what it would look like in the alternate definition. And I'm going to multiply by x minus 2 plus c minus 2 and x minus 2 plus c minus 2. Okay. So if I do that, I'll end up with a new limit. Well, same limit, but new pieces. So now I'm going to have x minus 2 minus c minus 2. And on the bottom I have x minus c and the square root of x minus 2 plus c minus 2. So if I collected up like terms on the top, this is why it kind of works nicer with square roots, is right away all that's left on top is x minus c. So it's going to get rid of that problem where I divide by 0. So x minus 2 plus c minus 2. So now that that's gone, as x becomes c, this would go to c as well. And that's going to give me a formula that says 1 over c minus 2 square root plus c minus 2. Okay, that's also known as 1 over 2 square root c minus 2. Same, yeah, this is the value if you give me a c. It's the same thing, right? It's the same thing, except now you're using a c instead of an x. So yeah, you're correct. You give me a value of c equals 2, it's the same thing as saying x equals 2.